Okay, this is going to be the last video in the playlist that deals with different classes of chemical reactions. And in this discussion, what we're going to do is deal with what we call the double replacement reaction. And I've written kind of a general definition for this. These kinds of reactions usually involve two reactants where an element from each of the two reactants changes places. These reactions, and we're going to do three examples to point out that double replacements happen in a lot of different contexts. However, one of the most common forms of double replacement reactions in chemistry classes that you're going to encounter is going to be the one that occurs during what we call precipitation chemical reactions. And so that's going to be the first example that I do. And that's going to be the reaction, the one that I've chosen is the reaction between silver nitrate, which is a solution. Again, so this is an ionic compound followed by the designation aqueous, which means that the silver nitrate is dissolved in water. And what we know is that when an ionic compound is dissolved in water, then it has to be separated into its ions. And the silver nitrate is being combined with sodium chloride, table salt, which is also in an aqueous solution. So one of the hallmarks of precipitation reactions, and actually a requirement, is that you are combining solutions, two solutions that each in itself has a dissolved ionic compound in it. The product that we're going to produce here is going to be silver chloride, which is a solid, a precipitate, a solid, a precipitate, a solid, all right? And a second product, which is going to be sodium nitrate, which is aqueous. So it's in the form of dissolved ions. All right, and what you can see here when you inspect this, the reason it's called a double replacement is because this cation here changed places with this cation. Okay, and this cation went over here and made it up with this anion. So the sodium came over here and combined with the nitrate. The silver came over here and combined with the chloride. That's why it's called a double replacement. In another way of thinking, these two metal cations changed dance partners. Now, if we very quickly go through and we do the net ionic equation, we see that for the first compound, since it's fully dissolved in water, we can write it this way. All right, and that's added to the second compound, which is going to be represented this way. We form the salt, or the solid, which we can't separate because it's not separated, it's a solid. But the sodium and the nitrate is fully separated because it's in solution. And notice that we can cancel the spectator ions. These would be the ions that appear on both sides of the equation. And the final net that we're going to write will represent, for a precipitation equation or reaction, will represent only the ions that produce the solid. Okay, now our next example is different. So we're going to take iron. This actually, to do the naming on this, to bring in another aspect, is iron 2 sulfide. And it is undergoing a reaction with hydrochloric acid, all right, which happens to be aqueous. All right, what's the rule of thumb on that? If it's aqueous, then the compound, if it involves ions, has to be fully separated in solution. And we're going to form in this reaction hydrogen sulfide, which is a gas, and iron 2 chloride, which is soluble. So it makes an aqueous solution, which means it's fully ionized. So we see this is a double replacement because the iron switches dance partners with the Cl, comes over here, mates up with the Cl, and the hydrogen, all right, comes over here and mates up with the H. I mean, with the sulfide. The H comes over here and mates up with the sulfide. So it's a double replacement. The two cations are switching dance partners. Now, if we write the net ionic for this, it's going to be the iron 2 sulfide, all right, with the aqueous solution of hydrochloric acid, which we write this way, to make the hydrogen sulfide gas. Can't split that up. It's a covalent compound. You can't split this one up, the iron sulfide, because it's a solid crystal. But we split up the iron chloride like this. And then we inspect both sides of the arrow, and we see in this case that the only thing that you're going to be canceling out is going to be the Cl minuses. So the net for this would be like that. Okay? Now, the last example is what we call a classic neutralization reaction. So this is going to be the reaction between hydrochloric acid and sodium hydroxide. Hydrochloric acid is one of the 6 strong acids that, if you're in a chemistry class, you probably need to have memorized, and the sodium hydroxide is one of the 5 strong bases. Oh, and both of these are aqueous. So they're fully dissolved and ionized, and we're going to end up producing liquid water and a neutral salt. Okay, and by the way, that's why we call this a neutralization reaction. So just to go over that definition quickly, a neutralization specifically is the reaction between an acid and a base to produce water and a salt. All right, that's the formal definition. And we see that this is a double replacement because the hydrogen switches dance partners with the sodium, and the sodium switches dance partners with the hydrogen ion. All right, if we do our net ionic, it's going to be H plus Cl minus, whoops, okay, plus Na plus OH minus to make water. We don't split that up. It's a coherent, unique molecule. And then we're going to have Na plus on this side and Cl minus because that's an aqueous solution. And when we come in and we cancel the spectator ions, the Cl minus, the sodium, Cl minus, and we see for a neutralization reaction that the net ionic, in particular for a strong acid in a reaction with a strong base, produces a net ionic that will be H plus OH minus to produce H2O. So here we have, there are 3 completely different types of net ionic equations. This is the classic precipitation. All right, and this one Quite frankly, I'm not sure what I would call this one. It's a double replacement. It's not a precipitation because we've formed a gas. We'll just leave that one. And then this last one we call a, formally it's a neutralization. The main point being is that double replacement reactions come in a lot of different forms and types.